our first use case is called the noisy ping pong simulation. And in this simulation, what we're going to be doing is we have Alice and Bob in our network, and we're going to be sending a qubit back and forth between these two nodes. And so the idea of this simulation is to see how our qubit fidelity performs over time. And this is going to be good to actually test some devices and equipment that we are maybe considering to build our quantum network. So these devices and equipment we're talking about are these quantum memories and quantum channels that we see on the screen. So let's take a look at what the network design looks like. Okay, so we have, in this case, we have two nodes. We have, as I mentioned, Alice and Bob, and each of them contain a quantum memory, which also holds one qubit, all right? And then we have a quantum channel to connect Alice and Bob, and through this channel, we're gonna be sending that qubit back and forth. So should we jump into our simulation script to configure these devices and see what the simulation results are?
Absolutely, that'd be great. Maybe while you're going to that, so a couple things. One is the fiber optic cables that are connecting Alice and Bob. Likely we would get some parameters from the telco or the carrier or the operator who's providing that fiber optic cable. They'd likely go out and make some measurements and provide us that input into this model. And then you mentioned the memories. There are memories that are being developed today. We're not quite at production commercialization of memories yet, but we would likely get parameters from those memory manufacturers, and you'll take all that information and put that into the model. Is that right, Michelle?
Exactly. So we're going to be taking these parameters and we're going to be simulating our network, taking into account that information that we're receiving, right? So, okay, so here is our script for, this is the part of the script where we configure the network. And we can see how we have already defined Alice and Bob as our quantum network nodes. And then down here, we have two quantum memories, one for Alice and one for Bob. And so we're going to be simulating the idle noise that the qubits are going to experiment as they are being stored in this quantum memory. And for this use case, we're going to be using a dephasing noise model. And this dephasing noise model essentially takes a dephasing time right here. And this is just telling us that, for example, if we set it to 300 microseconds, then this is the time that it's going to take for the noise to completely erase the phase information of the qubit state. So this noise is effectively going to be affecting our qubit fidelity. All right. And then down here, a little, further down in our script, we are defining our quantum link or our quantum channel that we will be using to send the qubit back and forth. So for this quantum link, we're going to be simulating two different parameters. We're going to simulate a delay, meaning that this is going to be, this is going to represent the time that a qubit is going to take to traverse the whole channel. And then we have also some channel noise that we will be simulating. So for the channel, we're going to be using a depolarizing noise model, and we're going to set a probability for that noise to happen on the channel. So for this first simulation, we're going to set it to 10%. So this means that there's a 10% chance that our qubit is going to experience noise while traveling through that channel. All right. So let's go ahead and run this simulation and see if these parameters actually, see how the network performs using these parameters. So let's run this simulation and save this into a log file that describes what happened in the simulation. So let's call this ping pong, or ping pong 1.log. Let's run our simulation.
Love that you're doing this live, Michelle. This is not pre-recorded or anything. This is a lot of fun to see this.
Yeah, totally. So we have already ran our simulation. We have our log file here ready. So it is important to note here for this example that, as I mentioned, we are interested in seeing the fidelity that our qubit is going to be, presenting during the whole simulation time. And so to do that, we're going to be, we prepared the script to peek at the state of the qubit at different times of the simulation. And then we're using a data collector tool that is a part of the Aliro Quantum Simulator that is going to be storing all of these fidelity values, and then it's going to produce a file that we're going to give to the visualizer, and we're going to be seeing these fidelity values throughout, the simulation. So let's go ahead and see what that looks like. All right, so we have our simulator, our visualizer here on the screen, and we're going to be loading our first file here. So the first file we need to give it is a network file, which is going to describe our network setup. And then we're going to give it a log file. So the log file that we generated for this first example, let me just remember the name, pingpong1.log. So this is our first log file. And then we're going to also be inputting the data collector file that we generated as well. So we hit visualize, and we scroll down a little bit to see what happened in the simulation. Okay. So what we're looking at here in the screen are our two nodes, Alice and Bob. And then we're also looking at a timeline of events starting at time 0. So we first see that Alice applies a Hadamard gate to her noise, and then to her qubit, sorry. And then that qubit is being sent over to Bob through the channel. And here is where Bob is receiving this qubit. And then we can see that actually Bob waits some time before sending it back to Alice. All right. And this happens, again and again during this simulation. And then to the right of the visualization, we can also see the values of fidelity that our qubit's it's taking, during this whole process. So what does this simulation look to you, Mike?
Well, I'm no quantum physicist, but what I'll tell you right now, Michelle, is it looks like I see the ping pong effect there, and I understand what that means now. It's bouncing the qubit back and forth. But one of the things that jumps out at me immediately is just from Alice to Bob, that duration of time, the resulting fidelity, I would imagine it starts at 1 with Alice, but then it drops pretty significantly to 0.949 once it gets to Bob. And then I notice there's also degradation from Bob back to Alice, and then Alice back to Bob. So to me, what jumps out, the only thing that looks like it's a factor there would be in between the memories, which the biggest thing there is the fiber optic cable. Mm-hmm. What could be causing that? Is it possible there's some issues with the fiber optic parameters that we got from the telco? Is there something maybe that they can improve there? What are your thoughts?
Yeah, so definitely this visualization is suggesting that there is something going on the, with the parameters that we established for the channel. Because, as you mentioned, we see that fidelity degrades as it travels, as it reaches the other node. So there's probably something wrong with that, parameter configuration.
So is it possible, maybe we go back to the telco and we say, we ran an analysis, a simulation, we visualized it based on the parameters you gave us. We think maybe there's some passive components that may have failed or degraded, or maybe there was a bond that was created in the fiber optic cable repair that was done. It wasn't quite done properly, or maybe where the fiber optic cable is located. Send them back to go analyze that. And let's say they come back to us with, we found a problem with the passive component. We replaced it, we remeasured, and these are our new parameters. Would you be able to load those into the model now, Michelle, and rerun it?
Yes, for sure. Let's go ahead and do that.